This video has been created to showcase the ICU Workbench application from G2 Research. The ICU Workbench is a solution that has been built to analyze location data, specifically GPS data taken from covert tags. It's made up of two pieces, an analysis engine and a Workbench interface. The analysis engine takes massive amounts of GPS data and can analyze it very quickly and produce meaningful intelligence and patterns out of the data that it's analyzed. And the Workbench is a way for an analyst, operator, investigator to go in and add more value to the data, interrogate the data, etc. The key features are efficiency. It can process huge amounts of data very quickly. 60,000 GPS fixes can be processed in a minute or two. Provides a great deal of clarity to the data. It takes the data from raw fixes up into something that can be viewed and understood by a non-expert, and it requires very minimal training. The Workbench itself is very intuitive to use. It's been designed specifically to be that way. We now have the ability to import data via our import wizard, so a user does not have to understand the data. They simply get a CSV file of GPS or location fixes and can ingest that into the application very easily. The only data elements that we require are a latitude, a longitude, and a timestamp, a date timestamp that is. And if we have those three elements, we can process the data. We don't require anything more. All vendors that produce covert tracking tags, their solutions are able to produce CSV files with those three data elements in it, and we can ingest data from every covert tracking and a bunch of commercial tracking devices that we've found over the past 2 years. We also provide some intelligent filtering of the data once it's analyzed, a way that an operator analyst can suppress travel and activity in the track that is not of specific interest. I'm now going to show you the application. We'll begin by importing some data and showing you how easy that is and how quick it is, analyze the data, and then quickly show you some of the results that we can get out of the application with basically no user interaction. So I'm going to show you an example of the files that we import. Simple CSV file. As mentioned, date, time, longitude, and latitude. That's all we require. Vendors do put in more data elements in there. We can use some of them, but it's not required. Every vendor that we found will produce a CSV file that has this data in it. And you'll see there's thousands and thousands of rows of data in this file. I believe there's 60,000, 61,000. And we are simply going to import this file. Click on the import button, call it. To name the file and then navigate to it. Now it launches the wizard, and the wizard, which has been pre-configured in this case, but it allows an operator to go in and define what these formats are. In this case, that is a date-time format. Date and time are in the same column, and you've got a whole bunch of options there: day, month, year, day, year, month, day. Etc. Well, in this case, it is set already to month, day, year. Longitude's there as well, so we can go down and say it's a position element, it's a longitude, and then there's a number of formats. The usual are in there, and finally latitude as well. So it's set up. The headers turn green when they're acceptable to the import engine. We click submit. The application is just telling us now that it's going to import 61,784 records. 100 have been rejected either because they're duplicates or they could have been damaged when the device was writing them out. They were interrupted for some reason, so it's going to throw out only 100 of about 62,000 records, which is normal. We're going to say yes, we'd like to import this file. And then we are going to, you'll see that the file is imported there. We're going to run a view of it. All I have to do is name it, and give it a time offset. In this case, we're 3 hours off Zulu or GMT. I'll leave it in metric and generate a view. Status bar is available. And we have just run 51 days worth of 5-second fixed data. It's generated a view for us. We'll very quickly jump into the application. The map will center on the geography that the target was operating in. And if I click our itinerary report button, this produces a report of all of the travel activity of the target. And I'm about a minute and a half or 2 minutes in from importing 60,000 fixes, analyzing it, and I can run this report, generate this report. It has every day in here itemized. I can go look at what the target did on, say, Tuesday, Wednesday, Thursday, Friday, whatever day I need to look at, it's all in here. And I can then save this off and send it up to an analyst group or out into investigators or operators, whoever's required. Going to continue on exploring the application in a little bit more detail. So in the last section, we imported data and created a view. We're going to use that same view and explain the itinerary panel or the pattern of life of the target. You'll see there's an interesting grid on the left-hand side of your screen. You'll see that days of the week are at the top, Friday, Saturday, Sunday, Monday, etc., and hours of the day starting at midnight and rolling down to midnight of the next day. At the bottom there's a legend to show what the color coding is in the grid. Our analysis engine has automatically found the target's home and work location when they're available, and it's color coded them that way. This is when the target is at home, this light blue color, and this slightly darker blue color is when the target is at the work location. This mauve color is when the target is at another location that isn't home or work, that hasn't been identified by an icon yet. And there's two shades of green. A light green travel, which shows that there's some travel in the hour, and a darker green color that shows that most of the hour was made up of travel. I can roll over these cells and get tooltips off them to show me what the target was doing during that time period as well. And I can also, as you would expect, plot this on the map. Here's the target driving in to work. I can interrogate the map. Travel arrow will tell us when the trip took place, etc. Not only can I plot an hour of time, I can also plot a whole day's worth of travel, as you'd expect. And this is the travel for that day. And again, it can be interrogated to figure out how long the target actually stayed. In this case, the target went to the red pin destination, which is destination 10, and stayed for an hour and 15 minutes. I can also go in and actually use this pattern of life grid to interact with the results. I can zoom to this destination, D14. And you'll see that we've zoomed into a parking lot here. I can then also update and say, well, actually, I know about this geography, and I can look at the destination details. Say there's a reverse geocoded address at the top, but I can also assign this an icon to provide some context on the map. And you'll see that the icon is changed to a jug of milk and an apple. Now that provides you some clues as to what the target might be doing there. I can move through this. There is 51 days worth of data that we've ingested into the application and analyzed. And I'm only showing 2 weeks here, but I can move through this on a day-by-day basis if I want, or in 2-week increments. And all of the data is in there. You'll notice I'm using Google Earth on this side as the map. Currently I have 2 maps open. The other one is OpenStreetMaps, which we support. And we actually support a number of other maps that I've listed here. Google Earth, OSM, Esri's runtimes, both 9.3 and now Esri 10. Bing, ArcGIS, and Google Maps. We've designed the application to support two configurations that are a little bit polar. One is where the analyst is working in a headquarters facility and he's got multiple monitors. These apps can be the maps can be detached and moved into separate monitors, and they update in parallel with each other. You'll see there they're both updating, Google and OpenStreetMaps. I can then reconnect it. And if I happen to be using a Toughbook in a disconnected fashion, the screen resolution is not as big as this, and the map tends to get cut off. Well, we've provided a facility to let the map be useful on a Toughbook in that scenario with our expand and shrink map button. I'd like to now show you some more results of our analysis engine. I'm going to use the same track that we ingested and the same view that we generated and go and look at the Destinations tab. And here you'll see all of the important destinations that our analysis engine has found in this track are listed. The engine has automatically found the home and the work location and given them home and work icons. And I've gone through and assigned the rest of these destinations with icons myself. And I've associated a few of these destinations with a group that I'm calling drugs. There's drug activity going on at these destinations. We can go in and look at the details for the visits to any of these destinations, and I'll pick the sushi restaurant. And you'll see the map will update as we zoom in on an icon that is a cross knife and fork. That's the icon that we're using to show that it's a restaurant. And there's a bunch of orange balls in there. Each one represents a visit to this destination. And if I click on it and interrogate the map, I can get the details. Those same details are reflected in this panel on the left-hand side. I can see that the information is here, but it's pretty hard to see that there's a pattern, or is there a pattern to this data? It's very difficult to tell. So we've graphically brought that data into a graph. And here it is. This is all of the time that the target spent at that destination. I can then also go and see all of the time that the target spent at any restaurants by using the activity of the same icon grouping. Here's all the time that the target spent at a restaurant. I have a legend here to show me what the color coding means. And finally, I can go and get a report on all of the drug activity, all the activity that was taking place at a destination that I'd put into the drugs grouping. And here it is. We're showing all of the activity at the locations that I've tagged in the drugs group. And again, a legend to show you the color coding in the graph. This can be saved off into in format so that you can stick it into reporting very easily. Next, I'd like to move on to the routes tab. Once you know the target's home and work location, it makes sense that you can start categorizing the travel, specifically the work commute. We do that by taking transits that are normal and putting them into the standard transit bucket, and then transit variations that are different, either by distance traveled or duration to make the work commute. We put those in a separate bucket, and finally partial transits. So I can display the standard transits for you, or a polygon that actually frames up all of that travel in the work commute. And switch maps, and it's a little more evident. There it is. That is all of the travel that is in a standard work commute fits inside that polygon. And I can also show you the destinations that the target visits on a normal commute. I can then also show you the locations on a non-standard commute that the target visited. Toyota dealership, a parking lot someplace. Those may be cues that there's something interesting going on. And you'll notice that the polygon that I draw gets a lot larger. Again, it's non-standard because the target is traveling longer, both in distance and in time. I can also go in and look at the actual details of the trips that make up this route. And here they are, and I can plot them as you'd expect. For example, I'll take these two. This is a standard transit from home to work. We categorize travel that way for most of these except the errands. And in the errands we do something slightly different. We don't have standard and non-standard transits of the routes. We just have short and long errands. And in this case, I can plot that for you. The green elements over here are just showing the short errands that the target's taking. I move on to the driving tab. We find certain driving events in our data, specifically braking, lurking, and speeding. And you can come in and zoom into events here. There's a number of them at this location. They're all hard braking events, and I can interrogate them from the map and see that the target was going 46 kilometers an hour. 5 seconds later, he was going 7 kilometers an hour. That could be interesting because potentially there was a collision there. I can get the same information. I can get the same information from the data panel on the left as well. One other thing we've brought into the application right now is a concept that we call external events. So these are events that are to do with the target, but not necessarily the tag that's on the target's vehicle. Could be financial transactions, the target using his credit card. It could be crimes that have taken place in the area that you're trying to see if this target is associated with. And I'll build one for you to show you what our intended use of this is. So in this case, I'm going to say that a murder took place, and I'll find an icon to show that there's murder. It's a homicide icon I'll use, but you'll see that we've got a whole bunch of icons in here. Surveillance, whether the target was texting, traffic cams, weapons-related offenses, if there's jamming going on, comms issues, etc., etc. And that activity took place at a location. I can type that in, the street address of it, if I get it right, and zoom to it. And it also takes place not only in a geography, it also takes place in time. But we know it took place here, so I'll draw that on the map. It took place in there somewhere. It's where the body was found, or we believe the body was murdered. And then we're also going to give it a time that the victim was killed. As I was on the 31st, in the morning of the 31st, so we'll set that up here. Somewhere between 6:30 in the morning and 9:48 in the morning, the coroner is telling us that the victim was killed, and I can update the map. Now, what it's doing right now is it zooms out. It's showing me what the target I'm tracking, what the target's track was at the same time or in this time frame that the victim was killed. And in this case, what it's demonstrating is that the body was killed, or the victim was killed here. Our target was a long way from that. At least his vehicle was a long way from that. In this case, this target is probably doesn't have anything directly to do with the murder of this victim. And I can add that event. Events can be shared across tracks as well. So if there were other tracks that this could be associated with, this would become highlighted, and I could then select the tracks that I wanted to link the event to, and then share them across tracks. So if I wanted to put in all of the calls for service, let's say from 911 calls, I could put them all in here and then apply them to all the tracks in the database and see if any of the targets in there were associated with any of the criminal activity. Another important element of our application is our multi-target analysis, and I'd like to walk you through how it works, explain a little bit about its abilities. So you'll see in the tree structure here, I'm going to select a folder called MT for multi-target, and I've got a bunch of tracks in there. Each track below it has a view generated, and I'm going to select one of them. In this case, I'll select view 1 from the Tom track, and I'm going to do a multi-target correlation between the Tom track and all of the rest of the views that are generated in this folder. This is happening in real time that we're doing the correlations. I just click on the tab and wait a few minutes for the results. And there we have them. So you'll see that I've used an anchor track of Tom. That's the Tom track is my anchor track, and I've done a correlation between all of the rest of the tracks in that folder: Bruce, Holly, Ray, and Tracy. You see there's a color coding at the bottom showing me that red is the most important linkage. Orange is very interesting, yellow is interesting, all the way down to green, which is not interesting. You see there's a bunch of not interesting green here. Maybe worth investigating, may not, but you see the Tom track and the Holly track are linked very closely together, and so I'd like to show you some of the linkages and what they mean. In this case, I'm going to select this destination, as there is a red one visit that correlates from Tom to the Holly track. I can zoom in on that destination to show you where it is. It happens to be in a parking lot, if you can see in the map on the right-hand side. And I can also go in and actually get a look at what the two targets were doing. So I can select the radio button and update the map. And what this is going to show me is what the Tom track was doing that our engine thought was a correlation. And here you'll see the green line show the target driving into this parking lot and parking the car. That's the target, the anchor target parking. And then you'll see our engine has found a correlation, which is an overlap during this time frame for 10 minutes and 20 seconds from the Holly track. And so I can then click on that as well, update the map to show me what she was doing at that same time. And you'll see these two vehicles are parked very close, 5 or 6 parking spaces away. It's fairly unusual that you'd have two targets that you have tags on at exactly the same time in a parking lot in a mall, and them not being up to something. So that's great. I can see that, but I'd like to get another view of it to show me how far that really is apart. If I had maps or didn't have satellite imagery, maybe I had maps and it was pretty hard to tell or gauge distance on it. We've done that work for you as well. I can come in here and say, give me a proximity profile, and our application generates a graph that I'll explain to you. So the y-axis here is the distance that the linkage is from the target track's visit, and the blue bar here is the time that the anchor target spent at that destination, and the red bar here shows the time that the correlated track was there. So the Holly target was there a little bit before Tom showed up and stayed till over, past half the time that the Tom track was there. Tom target stayed for a lot longer. And in the end, this is currently in meters, but if we ran it in imperial units, it would be in yards. Holly was 30 yards away and overlapped for a bunch of the time. So this is telling us that they were probably at least communicating during that time frame. I can save this off as a picture, put it in my reports, etc. I'd like to show you one that's a little bit more complicated so you can see what it would look like, and this may be a good one here. There were 16 correlations at this location, and we can go and look at it. So here it's showing us all the correlations, and I can go look at them and see what the targets were doing there. Well, they're parked fairly close, but you'll see, and they did overlap. And I can then go again produce a graph to show me what was going on. Well, the Tom target was obviously just doing a very brief errand, because you see the blue bar here. He's only there for a few minutes at most, as Holly was parked up the street 375 yards away for most of the day. She then drove to 2 other locations before this yellow correlation, which is still 350 yards away. That's a long way, and our analysis engine has done a pretty good job, I think, saying that this is an interesting correlation, but it certainly isn't that interesting, as they're far away for sure. They do overlap, but the Tom target was only there for a very brief amount of time, and it's showing this to you graphically. Lastly, I'd like to show you a little bit about the structure and setup of our application. So I'm in the Tracks tab right now, and we've got our tracks organized into folders. There's 3 of them there. Open up the New Tracks folder, and you see there's a bunch of tracks under that folder. And finally, there are views associated, or analysis views generated for those tracks. One important thing that we do is we allow the analyst to append data to tracks. And this changes the operational paradigm for a lot of our customers, that they can now take a day's worth of GPS data and in a 60-day warrant and continue to build up a 60-day profile a day at a time without needing to push this data back to an analysis group. They can also get the results very quickly. And I'd like to show you how that works. So I'm going to import a track, and in this case I'm importing 14 days. Runs through the wizard again. I've already set this up to ingest the data, so it works very seamlessly. And you'll see in this new tracks folder, I have a new track, and it's called the Tom A track. I'm going to generate a view of that very quickly here. And within a few seconds, it's going to tell me, well, it's already done. Great. So I have a view now of the 14 days of data. Well, I've got more data that's got to go in there. I've just received more GPS data from the field, and I want to append it onto this track because it's to do with the same target's vehicle. I simply import the data. You'll see 14 days is going to change after I've gotten done with the wizard. There, it's now 31 days of data, and it's telling me that the view that I just generated off the 14 days is now out of date because I have new data. Well, I can then go and run another view of this, and you'll see it just takes a few seconds here to make that happen. Oops, wrong name. And we're done. So, and this is now, I've just done another 14 days worth of data. It's taking me 30 seconds to add it up, and the results are cumulative. So if I've gone through and updated and provided context on the first track, all I need to do is as I'm generating, and I'll do it one more time where I append some more data on the third piece of this file. And let's say that I've spent a bunch of effort marking up view 2 here. Great, it's now 51 days worth of data I've got ingested. It's telling me that they're both out of date. Well, I want to generate another view, but I don't want to lose the analysis results from view 2 because I've marked it up a bunch. I use it as a referenced view. It's automatically set the time offset, and it will drag all of the destination information that I've assigned, icons, notes, etc. It will move them all into the analysis results that I'm just about to generate. And you'll see it's telling me that it's actually bringing forward the settings and all the markups from view 2, and we're done. So I've just brought 3 14-day files, GPS fix files, track files into the tool, run independent views of each of them, and the final one I've actually referenced the second view of that to make sure that I brought all the analysis results and settings forward. This is game-changing for some of our customers, as they used to have to bucket this up in week-long chunks to give to an analysis group. Then they could find the results and give it back, but by that time the data was already a few weeks old. In this case, if I got the data yesterday, a day's worth of data, I can add it on, and in 30 seconds I can then look and see what the target, not only what the target was doing yesterday, but are patterns now emerging out of the data that came before it. Something else we do that's important to show is a concept we have in the application called level of interest. Everything that the engine finds has an LOI setting on it. This is the level of interest value. The engine's gone through and assigned them, but an analyst operator can always override them and say that is an extremely interesting location for some reason, and set it as a 5. And we use this as a filter in the application to show only the most important things, so we can filter out some of the unimportant things that would be level of interest number 1. And how this sort of manifests itself in the application. If I go and plot a couple weeks worth of travel here, you'll see it's kind of spaghetti on the map. That's because I'm showing all of the data. Well, if I tell our application, just show me the most important things that happened during that time period and update the map, you'll see it's found one trip in that 2 weeks worth of data that in the middle of the day, and I can get the details by interrogating the map, in the middle of the day on April 9th, I drove for 40 minutes out into the country and then drove back again. I never did it before in the track file, and I never did it afterwards. And it's assigned this as the highest level of interest item in the track data, and it's done that correctly. So this is, again, a way to filter results. In this case, I am only looking at the most important thing that happened in that 2-week period. If for some reason I needed to get this to somebody, I simply click on this button and I automatically generate a picture of that travel.